For question number 8, we're asked to give ordered pairs that are solutions and graph the equation. The equation given is 5y equals 4x minus 20. Complete the ordered pairs so that they are solutions to the given equations. The first value given in the table is a point where x is equal to 0. We plug 0 into the original equation for x. Yeah, 5y equals 4x. Instead of x, we're going to replace it with a 0 minus 20. Simplify this. We get 5y equals, we know 4 times 0 is 0. 0 minus 20 is negative 20. Divide by 5. So we get y is equal to negative 4. You plug that in, which I've already done, into the space provided. And then the next thing that comes up is you have a 0 in the y position. We're going to replace the 0 in the original, the y in the original equation with a 0, and then solve the equation for x. When you simplify, 5 times 0 is 0 equals 4x minus 20. When we add 20 to both sides, we get 20 equals 4x. Divide both sides by 4, and we get x is equal to 5. So we plot that point, or enter that value in the space provided. Now with those 2 points, you can sketch the line. We've actually found the x-intercept and the y-intercept. I'm going to zoom in and show you how we use the tools to sketch the line once we know the x and the y-intercept. When you open up the graph, enlarge the graph, there is a button that is a line tool. You plot the first point, which is 0, negative 4. And that is the point right here. Click that. And then you find the point 5, 0. Click that. We see the line here. You can click on the point and you can see up here that that point corresponds to 0, negative 4. Click the point here and you see that that point is 5, 0. Save your answer and check your answer. And we see that that is how we graph a line. Number 9 is similar. Here we want to complete ordered pairs for the equation and then graph the equation. Here we want to find the point that corresponds with 0 in the first space and then a blank in the second space. This is the same thing as in the table. 0 is in the x column, so we need to figure out what goes in the y column. When we take the equation and replace the x in the original equation with 0, oops, that should have been a plus sign, sorry, equals 10, and we simplify this, so we get 2y equals 10, and then divide by 2, we get y is equal to 5. So that's the value that goes into the first equation, in the first space provided. The next space provided, you have a 2 in the x position. I'm sorry, you have a 0 in the y position. So we plug in the original equation, replace the y with 0, and when we simplify that, we get 5x plus 0 equals 10, so we get x equals 2. So you would put a 2 in that position, so we have 2 corresponding points. We can either click here or there to graph those 2 points. Using the line tool, I'm going to find the point with coordinates 0, 5, and then the other point 2, 0. Save it and check your answer. Number 10. In this one, we are asked to graph the equation y is equal to x squared plus 3, and then choose the graph from the choices provided. What I like to do when I sketch a graph and I can't tell right off the bat what the graph is, I usually tend to make a table of values. And in that table of values, I usually try to graph a couple negative values for x, a couple positive values for x, and even 0. And I take those values, I plug it into the x in the original equation, and our equation was y equals x squared plus 3. So whatever you plug into the function here for x, you're going to square it and then add 3 to it. If you take negative 2 and plug it into x here, negative 2 squared is 4, and 4 plus 3 gives you 7. So that's going to be one of the points that's on the graph. Plug negative 1 in for x. Negative 1 squared is positive 1 plus 3 is 4. Let's plug in 0 for x. Put 0 in for x here. You get 0 plus 3 is 3. Plug in 1 for x. 1 squared plus 3 is 4. And plug in 2 for x. 2 squared is 4 plus 3 is 7. Now each of these pairs of numbers corresponds to a point on the graph. If I were sketching this by hand, I would go negative 2 on the x-axis, up 7 on the y-axis, and plot my point here. Then I would go negative 1, up 1, 2, 3, 4, 0, up 1, 2, 3, over 1, up 4, and over 2, up 7. This is positive 2 on the x-axis, and this is the y-axis. Connect those points with a curve, and we see we have this parabola shape. And that parabola shape, if you look at all the choices, most closely resembles choice D. Excellent. We have 2 more questions for this section. Here we're asked to graph this equation, y, which is equal to the square root of x minus 4. And again, I typically like to make a table of values, but here we need to worry about what types of numbers you can plug into the function for x. Let's do this. Okay. So again, our x in our table and our y, which is equal to the square root of x minus 4. Again, I typically try to do some negative numbers. Let's say negative 1, 0, positive 1, and start plugging in some values. But I'm going to run into a problem here. If I plug in a negative 1 for x, the answer I get is negative 1 minus 4 is the square root of negative 5. This is imaginary. We are not going to be able to graph this. That negative 1 is not part of the domain here. It's not a valid number that you can plug in and get a real number out. So we're going to cross that one off the list. That is not going to work. Let's see what happens if we plug in 0. If we plug in 0 for x, we get the square root of negative 4. That's also imaginary. It's not a real number. So let's cross that one off the list. If you try 1 for x, also that's going to be imaginary. Plug in 2, plug in 3. Well, the first one you can actually plug in and get a real number out is positive 4. If you plug 4 in for x, you get the square root of 0, which is 0. All right, so that's the beginning of our domain, is when x is equal to 4. Let's plug in 5. Y is equal to the square root of 5 minus 4. Well, that's 1. 5 minus 4 is 1, and the square root of 1 is 1. And let's do, if we do, I'm going to skip a couple so I get a nice real number out. Let's try 8. 8. Y is equal to the square root of 8 minus 4. First you take 8 minus 4, which is 4, and take the square root of that to get 2. So that gives me 3 points that I can make a quick sketch of. 1, 2, 3, 4, 0, over 5 up 1, 6, 7, 8 up 2. And this graph is going to go like this. So out of all the choices, the one that looks most like our sketch is choice B. And if any time you need a closer look at any of these little graphs, just zoom on in and you can see, well, 1, 2, 3, 4, that is where this graph starts. In this scale, the scale is by 2 units. Choose B. And good job. Well, finally, our last question for section 2.1 is an absolute value graph. We want to graph the equation and choose the correct graph. Y is equal to the square absolute value of x minus 6. And again, I would typically make a table of values and plot some numbers here. But I want to make sure I choose enough numbers to get a decent looking graph. Oops, let's make a table. I would like to pick some numbers here. If I choose -1, 0, 1, 2, 3, so on. Actually, let's go by twos here, just to maybe so we get a larger look at the graph. When you plug the numbers in here, we get -2 minus 6 is -8, and then take the absolute value to get +8. Plug in 0. 0 minus 6 is -6. Absolute value is 6. Plug in 2. 2 minus 6 is -4. Absolute value is +4. Plug in 4. 4 minus 6 is -2. Absolute value is +2. Plug in 6 because 6 minus 6 is 0. Actually, that's the smallest y value that we're going to get out. And if you plug in 8, 8 minus 6 is 2, and the absolute value is +2. Translate those to points on a graph. So it's going to be -2 up 8, 0 up 1, 2, 3, 4, 5, 6, over 2 up 4, over 4 up 2, over 6 up 0, now over 8 up 2. Now if you don't plot enough points, you may not see that this line is going to actually go down and go back up. It's important to draw enough points so you can see the whole complete picture. Sketch those, goes down, and then after you get past +6, this graph is going to continue to go up. This graph out of all of them looks most like choice B. Well done. So that concludes the problems for section 2.1.